Okay, so my name is Kimberly Collins, and I want to give y'all a very brief, high-level introduction to databases today. A little bit about myself first, give you an idea of why you're listening to me in the first place. I've been a .NET developer for 12 years, heavy in SQL Server. I got started by taking a class in Oracle at OKC in 2006, so I've been doing this for a while. One of the main things I do, I'm a freelance consultant. I design, develop, and maintain SQL Server databases. So this is my first language, first love. I could talk about this all day, but I'm going to try to keep it to 20 minutes. So first off, I want to talk about why I even learn about databases in the first place. I've been hearing more and more developers, especially front-end developers, say, I don't really need to know about the database. I just focus on the front end. And I want to tell you that I disagree. First of all, the database is what holds your data for your application, so it's extremely important, an important part of your system. But more so, it's not really about the database, it's about the data. It's about the relationships between the data. And that's the focus of my talk today, is just don't be intimidated by the database. I think some people are, especially if you're working on the front end. You feel like it's intimidating or scary. It's not. I'll go through just the very basics in this talk. I'll be talking about just relational databases. There are other types of databases, non-relational. That's not what I use. That's not what I'm familiar with. We're going to be going through relational databases. And they store data in tables that relate to each other. So you can think about this. If you're not familiar with databases at all, you can think about a spreadsheet. Spreadsheets are absolutely not relational databases. They definitely have differences that we'll go over, but they do have similarities. So a worksheet is kind of like a table in that each table is going to represent a type of entity. So some examples would be product or person, and then each row or record in that table represents a particular instance of that entity. So a particular person or a particular product is in each row. And then the columns, just like a column in a spreadsheet, each one represents an attribute or a property of the entity. Some relational database systems that you might be familiar with. The one I work with is Microsoft SQL Server. I think MySQL and Postgres are more common with Ruby. And then also you'll hear about Oracle. So those are some of the most common ones. So the first thing we need to talk about when we're talking about a relational database system is entities. What does that mean? Well, those are the nouns. So when you're talking about the system with users or your business analysts, they're going to be talking about the functionality of the system, and they're going to be using nouns. So keep track of these if you're designing a relational database, and very likely each noun they use is going to represent a table. So if we're designing an enrollment system, students are enrolling in classes. Students and classes are almost certainly going to be tables in your system. Or if we have a order management system, customers can create orders, and those orders can contain multiple items. Customer, order, and item are definitely going to be tables in this database. So the main thing we're concerned about is the relationships between those entities. So once you kind of define which entities we're talking about, you're going to start thinking about how they're associated with each other in the system. And this is the main point of your relational database. The question we're going to be asking ourselves over and over is whether an instance of one entity can have or belong to, and those are the words we're always going to be using, have or belong to, or associated with one instance or more than one instance of another. And we use the term many just to mean more than one. So the difference between one and more than one is huge. The difference between 2 or 3 or 4 doesn't really matter at all. It's just, can there be one or more than one? And I'll go into some examples so that I hope that this makes more sense. The principle that's going to be guiding us is normalization. It sounds maybe scary. If you look it up on Wikipedia, it's definitely scary. Don't be intimidated. It's just the idea of breaking data down and organizing it into tables and columns in your relational database. And the idea is that we're doing this to optimize for data storage efficiency, not human readability. So I think one concern that people have when they look at a normalized system is, this doesn't make a lot of sense to me. Well, it's not for you. So if you're coming to this from like a JSON mindset where you have an object, any object system, you have sort of everything you need about the object just right there, and this is the opposite of that. So we're breaking data down across multiple tables for data storage reasons, and that makes it less human readable, but we'll get more into that. So an example of some unnormalized data, you'll see this is a very common setup for spreadsheets. You've got some data about some people and the classes that they're taking. You can hardly talk about this without using the examples of students and classes. I think that might be like a law, I'm not sure. But these are some examples of students and the classes they're taking. And the first thing that just almost hurts me to look at is the repetition of data. So you kind of might think like, oh, it's good to duplicate data, like the more the merrier, but definitely not. Like we would like to store each thing exactly once. And in normalization, the first step, so to speak, is called first normal form. There are 5 rules for that. The first one is that each table represents one entity. So the main problem with that unnormalized data is that we were representing multiple entities. We were representing people and classes and their enrollment in those classes. Each table needs to be for exactly one entity. Each row in the table needs to be unique, and that's often not the case in a spreadsheet. A primary key is going to identify each row. Rows and columns can be in any order. There might be a logical order for your rows or a logical order for your columns, but if the table doesn't make sense anymore, if you change the order of those, then you're violating first normal form. And again, that's something you'll see very often in a spreadsheet. It's like, well, don't sort this spreadsheet because then everything's messed up, or don't change the order of the columns because it messes everything up. That's not going to be true in a relational database. And then we don't really use the term cell, but if you're thinking of Excel, each cell can't contain multiple values. And you'll see this a lot for things like phone number. There's a column for phone number. Oh, we'll do my home phone number, my cell phone number. I just put both, comma separated, it's fine. That would be fine in a spreadsheet or a normalized data, but it's not fine for normalized data. We talked about primary keys. Those are the unique identifications for the rows. Very often that's just going to be an identity, which is an auto-incrementing integer, so just 1, 2, 3. In an intermediate table, which we'll talk about later, that can be the combination of multiple columns, but if it's not an intermediate table, very often it's going to be just an auto-incrementing integer. So the types of entity relationships that we'll have, one-to-one sounds like it would be very basic and common, but you almost never see that. In fact, I've had very few of these, and it's very common for a database to not have any at all, so I'm not going to talk about it any more than that, one-to-one. The 2 that we need to talk about are one-to-many, which is abbreviated 1:M, and then many-to-many, which is abbreviated M:(N). So one-to-many and many-to-many are the ones we're talking about. An example of one-to-many would be customers and orders. One customer relates to many orders. You can have no orders yet, you can have one order, and then we just use the word many to mean more than one. So that could be 2 or 2,000, it doesn't matter. And then the reverse is not true. One order has to belong to exactly one customer. You can't have an order that is not for a customer, that makes no sense. You can't have an order that belongs to multiple customers, at least in this example, maybe in some other. And so this will be a question that you need to ask, either just to yourself and say, okay, just one, or maybe to your business side. Can an order relate to multiple customers? If so, I really need to know that. So this is the question that you'll be asking just over and over and over. An example of many-to-many is our students and classes. One student can have any number of classes, none yet, one, more than one, and vice versa. One class can have any number of students, none yet, one, more than one. So this is many-to-many, many students relating to many classes. So this relationship has to be represented by a separate entity. And I think this is where people start to get a little confused. It's not intuitive when you're talking about relational databases, but we do need this separate entity. Sometimes it'll have a name that makes sense. The relationship between students and classes has a name called enrollment, and so that's what we're going to name this relationship. But many times, like with orders and items, there's no great name for that I can think of off the top of my head. So we're just going to call that item order, order item. It doesn't really matter, but you're combining those terms in a way that makes sense. So a little diagram I've made to show both one-to-many and many-to-many. And this is what I do. People think that it is very high tech and you're on the computer, but I like to step back and literally use a marker board and draw this out. I find that drawing lines between the boxes just kind of helps me think more creatively, makes me see things in a slightly different way, because it's not really about the computer, it's not about the database. So pro tip, you're going to write the name of your entity first, then draw a box around it instead of the other way around, because the box is never the right size. So I wrote the word customer, box around it. Order is something that I want to see how they relate. Write the word order, draw a box around it. The line between customer and order is representing that one customer can have multiple orders. So just one pointing to customer, but then 3 representing that one customer can have multiple orders. And the next thing I want to think about is how the items in my database relate to the orders. And so you might be tempted to draw a line directly between those two because orders contain items, items are in orders, but we would need to put this crow's foot on both sides because one item can have many orders, one order can have many items, and you're not allowed to do that. We have to go through this intermediate table that I called order item. So one order can contain multiple items, and that relationship is here. One item can be for multiple orders, and that relationship is here. And those lines are foreign keys in the database. So that's the relationship between a column in one table and almost always a column in another table. It actually could be in the same table, but usually we're relating one table to another. So the example here, the first one I showed was customers and orders. The order table is going to have a customer ID in it, and the customer table is going to have an identity ID. And customer ID in order is a foreign key to ID in customer. So just to look at that part of the diagram again, we see that the line between these two tells me that order points back to customer. And the important thing about foreign keys is that they are constraints for your system. So I think a lot of developers are tempted to just say, oh, I'll just deal with this, in the application itself. I don't need a foreign key constraint. And to me, that is kind of the whole point of relational database is to enforce integrity. We really don't want to have, for example, an order that belongs to customer number 123, and there is no customer 123. Like, who does this order belong to? What happened here? So that's the main goal of our foreign key constraints is that the value in the column has to already exist in the column you're referencing. So in that example of customer ID 123 in the order table, that has to already exist, the 123 customer ID in the customer table. So in our many-to-many relationships, that order item example is, and we call it intermediate table, joining table. I've heard lots of different terms, but I think intermediate makes the most sense because you can think of it as literally being between the two entities. And that's going to have a foreign key back to both of the original two reference tables. So back in our diagram, order and item have a many-to-many relationship. Order item is going to have a foreign key to order. So we're going to see an order ID in the order item table. And there's also a foreign key to the item table. We're going to have an item ID. That might be the only two columns in that table. There might not be a separate ID. There might not be any other fields. It's very common to have an intermediate table that only has the two IDs from the tables that we're referencing. Here's an example of enrollments. I have a student table where I've just listed me, Aaron, and John. I have a course table where I've got some courses. And then the enrollment table is the intermediate table. And there might be like an enrollment date, there might be other columns, but the ones we care about are student ID and course ID. And this is where I think people start to get confused, like, well, just looking at the enrollment table and ignoring the left side of the screen, these numbers are meaningless. So like, it kind of bothers people, I think, to only see those numbers, but that's okay. Like, it's not about you, it's about the computer. I've done a whole separate talk that I'll mention later on how you fix this, how we put these back together to see data that's meaningful to users. So student ID 1 is related to course ID 1, et cetera. These values have to already exist in the student and course tables. So some purposes of normalization, which has been kind of the underlying theme of all this, break everything apart. We want to impose integrity. Having an orphan record is bad. We don't want to have an order that belongs to no customer. We need to impose integrity. We also want to reduce redundancy. And again, redundancy kind of seems like it might be a good thing. You definitely want backups of your entire database. But within the database, redundancy is a bad thing. That will save space, which is not a huge concern, but it is something to think about. You want to store each thing one time. But then the main reason we do this is to avoid anomalies. So thinking back to that table, the unnormalized data, it had my name in there several times. Well, what if there's a typo in my name? Okay, now we have to find every single time that it was me and not some other Kimberly Collins and change that data. So we're avoiding anomalies. So the question that you're going to be asking just over and over and over until you're tired of it or your users are tired of it is, can one of these be associated with more than one of those? So is it just, and then vice versa. So we have an order, can it be associated with more than one customer? Back on this example, I've taken one step towards normalizing, but then the next step is going to be I need to do something with department. One thing you're going to be thinking about in the back of your mind is, like, can a course be associated with multiple departments, or are those different courses? So that's the type of question you're going to be asking over and over and over, is can one of these be associated with more than one of those, and vice versa? Because that will tell you whether this is a one-to-many relationship or a many-to-many relationship, and that's what we need to know to determine whether to create that intermediate table. So if you want to learn more about databases, on our YouTube channel for Techlahoma, there's the talk I did at SheCodes about sort of the opposite of this, which is bringing the data back together in a way that makes sense. Check that out. A lightning talk I did. There are a few other talks. If you just search for SQL, you'll find. If you have questions, I can take a couple of quick questions now, but the best place to ask them would be in Slack. We have a databases channel, or you can message me personally. I could talk about this just all day long. I love this. This is the main thing I do for work, so if you're interested in me helping you out at your company, please let me know, and I'll take any questions now. Do you have a question?
Yeah, so that intermediate table that you showed, is that sort of just like basically serving as a mapping?
Yes, you could definitely think of this as a mapping. Enrollment is a map, yes. The question is whether you can think of the intermediate table as a mapping. And yes, you could. This table shows the mapping of the students, which students are in which courses, and vice versa. If I have a course, which students are in it. So yeah, you can definitely think of it as a mapping table. Any more questions? No? Okay. Please ask any more that you think of later in Slack. Thanks.